Hello everyone, and welcome to the presentation of the paper Guide, Creating Semantic Domain Dictionaries for Low-Resource Languages, here at SIGTIP 2024. This work is a research collaboration between the Hasso-Plattner Institute and SIL International. And this is us, the authors. We will look at 6 aspects of this work. What is the global language documentation gap? What are characteristics of our dataset? How do we build a graph from this data? How do we build new dictionaries from this graph? And then evaluation and conclusion. Here's a quote. Languages shape our tools, and our tools shape languages. Who do you think said this? Yes, it's ChatGPT. Who is an expert on language tools if not ChatGPT? Today we won't talk about ChatGPT, but about another language tool, Guide. Guide is a graph-based unified indigenous dictionary engine. To get started, what is the global language documentation gap? These are all living 7,168 languages on Earth, colored by region. More than 7,000 of them are still low-resourced, which means that the availability of documents in these languages is very limited. In 2001 and 2002, the linguist Melo invented SIL semantic domains, which provide a scaffold to document any human language. Here you can see a drill down into the tree-structured hierarchy of semantic domains. There are 9 top-level semantic domains. The semantic domain 5, daily life, for example, has a subdomain 5.6 cleaning. 5.6 cleaning has 5.6.2 base. And 5.6.2 base has semantic domain questions abbreviated as SDQ. One question is, what words are used to refer to the action of taking a base? For each question, you can collect dictionary entries that answer this question, such as base or take a base. In the following, we also use the term word semantic domain question link for a dictionary entry because each word that we can link to a semantic domain question is an entry in a semantic domain dictionary. You probably know bilingual dictionaries that show you an English word and its translation to French or German or so. This is a useful parallel data source, but it does not scale when to tens, hundreds and thousands of languages. Semantic domain dictionaries do, and that's why we call them multiparallel. While bilingual dictionaries rely on one-to-one word translations, semantic domains group words with similar meanings, which is more flexible. Translated words often have different semantic ranges, and semantic domains provide flexibility to put them into the same group even if they are not perfect synonyms. The main contributions of our work are that we add entries to existing dictionaries and find entries in languages with no existing dictionaries. At the top, you can see an English semantic domain question with 3 new entries, the green ones. At the bottom, you can see the same semantic domain question with 7 new entries in the language Mina-Gen, out of which 2 are incorrect, the red ones. Mina-Gen is a low-resource language spoken in Togo. In total, Guide predicts 33,000 correct and new word semantic domain question links in 20 languages. To the best of our knowledge, we propose the first automated approach to link words to their semantic domain question. Therefore, we also establish a new benchmark, which makes us state-of-the-art by default. If you want to try out Guide on your own, you can visit this GitHub repository. How does our dataset look like? This is a summary of 6 large and useful public parallel corpora. We chose the eval corpus, which covers 833 languages, the highest number we found. We selected 20 languages with Bible translations. It contains 12 development and 8 zero-shot evaluation languages. For the 12 development languages, we also have semantic domain dictionaries, which means labeled data. For the 8 zero-shot languages, we have no semantic domain dictionaries, which means no labeled data. 10 of these languages are low-resource languages, according to a definition used by Meta AI. Moreover, Our dataset covers 7 different language families. After tokenization and some filtering, we have almost 200,000 words in our dataset. This gives us 10,000 words per language on average, which corresponds to a basic vocabulary. How do we build a graph from this dataset? The word alignment tool eFlomal aligns parallel sentences and verses in any language pair that can be tokenized. The image shows a multilingual alignment graph of a verse in English, German, Spanish, and French. We overcome noisy alignments by aggregating alignments. Each word in each language becomes a node, and all the alignments between two words become a weighted edge. The weight is the alignment count of these two words. This image shows an excerpt from the resulting aggregated multilingual alignment graph, abbreviated as MAG. You can see the word grandchild and its aligned words in French, Spanish, Portuguese, and Minagen. The adjoids have been normalized. The blue node at the top is not a word, but a semantic domain question to which 4 of the words have been linked. The question is, what words refer to the children of your children? There are 4 word semantic domain question links because these 4 words are from development languages, while the Minagen word Mama Yowayoa is from a zero-shot evaluation language. A margin note, a Minagen speaker told us that this word refers to the grandchild of a female person. This leads to the question, how do we add Mama Yowayoa as a dictionary entry? How can we automatically link it to its semantic domain question? Spoiler alert, we only need a single graph neural network layer. That's it, our model architecture. Just one graph convolutional network layer. A graph convolutional network is a special type of GNN that convolutes nodes similar to CNNs. Each node learns about itself by looking at its one-hop neighbors. A 2-layer GCN corresponds to a node learning from its one-hop and its 2-hop neighbors, and so on. Guide uses sigmoid as nonlinear output activation function and a threshold of 0.999. This means that we only accept predicted word semantic domain question links for which the model is sure to be correct. For each node, we use 4 node features: node degree, weighted node degree, semantic domain question count, and semantic domain question links. Because we have 7,425 semantic domain questions and 3 additional features, we end up with a 7,428 times 7,425 parameter weight matrix. The first value of the output feature vector corresponds to the likelihood that the respective word is linked to the first semantic domain question, the second value to the second semantic domain question, and so on. You might be wondering, does this work? To evaluate Guide's precision, we handed out 1 questionnaire for each of the 20 languages. It is a random selection of 100 to 120 predicted word semantic domain question links. The participants answered whether this prediction is correct or not. This table summarizes our results for each of the 20 languages. We evaluated Guide both using the dataset on the left and with the questionnaires on the right. Here are 3 key observations. Guide's average questionnaire-based precision is 0.65 and its dataset-based recall is 0.046. A second observation is that Guide predicts 2,400 dictionary entries on average for the zero-shot evaluation languages, which corresponds to 22% of their known vocabularies. If you look closely at the table, you see that German, which is the only high-resource language in the zero-shot evaluation set, might inflate this number. Even by only taking the other 7 low-resource languages into account, we still get 2,020 links, which corresponds to 21% of the known vocabulary. This means that Guide predicts 12 correct dictionary entries for the 7 low-resource languages in the zero-shot evaluation set per 100 words in their vocabulary. This sums up to 12.5 pages of text if you only write down the words separated by a space. Of course, the dictionaries would be about an order of magnitude longer because they also tell you what the words mean, not just the words. According to the linguist Ronald Moe, it would take 9 years to collect such many dictionary entries without semantic domains. Let's conclude. Guide is a tool to create dictionaries in low-resource languages. It uses the eBible corpus, SAL semantic domain dictionaries, and eFlomal to create a multilingual alignment graph labeled with known word semantic domain question links. A graph convolutional network convolutes this graph to predict 33,000 correct and new dictionary entries in 20 languages. Our main limitations are incorrect and missing predictions, which is also the reason why we don't know which are the correct and which are the incorrect entries that we predicted. Therefore, language experts can use Guide as a co-pilot. Thank you for your attention.